Alright, now to the final topic of this section, which is the library. We know from previous lectures that the library is the collection of reusable code. We often prepare the library to avoid rewriting monotonous parts of the code and to use it across the applications or in the application itself. I'll just give you an example of a library that we use more often, which is called the CoreLib. And inside this library there are various namespaces, and inside this namespace there is a class called math, which is inside the namespace called system. So if you go to the object browser and you go to my solution math, you'll find it in here, system.math. And you can find all the methods inside this class. Now, before I start using this class inside system namespace, I will just show you whenever we try to write a function to calculate the square root, how tedious it will look. First of all, we're going to begin by creating a square root function, and it will receive, and we'll assume hypothetically that it will calculate the square root for a perfect square number. So I'll receive a number, and then if this number is less than 0, then simply just throw an exception, invalid number or negative value. And if the number equals 0 or 1, then simply just return the number. And if the number is more than 1, then do a for loop starting from 1 and until less than number I++, and if I multiplied by I equal number, then return I, otherwise just keep on going, continue. And if you didn't find anything, then just return -1 if you couldn't find any square root. And now let's assume that we are going to pass square root 25 and then F5 to start with debugging, and that will calculate 5. Alright, now imagine that we have to write this across the application every time when I use the square root, or if you want to use it more often across your applications, if you have more than one, you have to write the same monotonous code, the same repetitive code. So to avoid this strenuous effort, you just have to use math, and math as a class is inside a namespace called system, like I told you, and system is inside core library, which is in system.private.corelibrary, or CoreLib we call it. And inside this math class you can find something called square root. If you navigate, which is here, and it receives a double, right? Square root receives a double and gives you back the square root. So you only have to either use system like this, or it will be implicitly used. Oh, this has to be an uppercase, or this is actually implicitly used, so you don't even have to write it. You can just simply pass in the value using math dot square root and then 25, and it will show you the result. Now compare between the two applications, and you can use this in any application that you write because it's a library. You just have to browse through the library, or if the library wasn't imported in your application, you just have to import the library in your application. So, but you can use it nonetheless. So now we'll exhibit this class that exists inside the library and see how it could facilitate your work. So let's write an application. Let's write like double number equals 16, and then double square root of this number equals math dot square root number, and then we'll print it out. The square root of the number is just to keep the consistent pattern, square root. Okay, and also let's declare a base number 2, and then an exponent of 3, and result. And now we're going to use the power dot pow, and then the base number and the exponent. This means 2, which is the base number, to the power 3. So that should the power of let's say base number to the power exponent is result. What else? We can also round the number. So if we have double decimal number equal 3.75, and then rounded number, and we chose to round this number, round, and then the decimal number. Let's see the result. The rounded number of decimal is rounded number Okay, now let's see the result if we executed the application. So the square root of the number is 4 because the number is 16. 2 to the power 3 is 8. The rounded number is 3.75 the rounded number of 3.75 is 4. So can you imagine if we have to write the functions to calculate all of this for us? What would it look like? It would look like horrendous, really. So now we're going to learn how to make a library for yourself, the DLL library, and then use it inside your application. Now let's create a library for ourselves, and in order to do that we need to go to the solution, right click, add new project, and inside new project we just use the project class library, and then next call it basic operations, and then hit enter and create. That will create a namespace called basic operations, and inside this namespace I'll just call it like basic math, and inside of this I'm just gonna create a function called add, and it will receive two numbers. I'm using the Pascal case, integer x and integer y, and then return x plus y. And I'm going to create another one called subtract, to subtract two numbers. Subtract, and this will take x and y as well, and it will subtract them from one another. So now just go to build solution, or Control Shift and B, and this solution is built. Zero warning, zero error. It has completed successfully. Now you can go to the Solution Explorer again, and inside the libraries, which is the previous project, right click, add project reference, and then basic operations, which is the library that I've just created, or the project that I have just created, and OK. And then you can go to the program.cs inside your libraries project and delete this using the namespace, which is, the name of this class should be basic math, so I should change it from here as well. Rename, okay, basic math. Okay, and the name of the namespace is basic operations, so I'm just going to copy this name, and inside my library program.cs, basic operations, and now I'm just going to define an object of basic math. Okay, addition called, I'm just going to name it addition equals new basic math. Okay, or you can define this as static, and then you can use it just directly. It doesn't matter. Addition dot add, okay, 5 and 6, and save this inside numbers added equals. I'm just going to copy this line and use subtract and slightly change this numbers subtracted, and then the addition result is numbers added, and then the same line, the subtraction result is, okay, F5. Now you can use, as you can see, 5 plus 6 is 11, and 5 minus 6 is minus 1, and you can use this library across your application or your applications if you have more than one application, or even you can export it and start using it in the different solutions as well. So that's it for this section. In the next lecture, which will be the last one, we will see a problem that we have to solve using all of the skills that we acquired from this section. So just try to practice really good for you to be able to solve the next problem by yourself and compare your solution to mine. Thank you so much.